Good morning. It's been a while since we've been here, and there's a lot that's been done. Some of it you will see today. But one of the things I really want to make sure everybody understands is why we're using bar joists. Excuse me. Why we're using the system we use in this application. There's many different ways to proceed. Concrete columns, concrete forms, concrete beams. In this case, we're using a combination of poured walls, columns, steel columns, and bar joists. Whenever you see bar joists and whenever you see columns coming down, you'll see that we hit point loads. We've talked about those in the past, where we do pile taps and point loads. This house that we're building is not the traditional, what we used to call birthday cake house, where one structural wall on one floor sits on top of another structural wall on another floor and carries up. You'll see that hotels and most commercial construction is the most efficient way to do it, because you're carrying all your load straight down. Houses we're building these days require a lot more open plan. People want limited walls from wall to wall. That kind of kills the whole idea of the birthday cake effect. It also changes in that people want tall ceilings, taller ceilings. 10 foot, 11 foot used to be acceptable. Not really what's acceptable anymore. In a luxury home building, people want 11 foot, 12 feet. In this case, a few rooms, they want 13 feet. So in order to achieve that, we go to a bar joist system, a steel beam system, and we'll get into that. Okay? Just to reiterate where we were, when we started last time we were here, we had just done the 740-yard pour. We started doing the block, we started doing the perimeter walls, and if you look, we just started getting in piles for the pools, etc. in the back. Time went on, which you'll see today in the video as we go through. We got the main floor steel deck in, okay, which you're about to pour, okay, and everything that goes into that. Now, in order to get to this point, we had to go through a whole set of structural integrity issues, such as...
How many cases of water?
Lots of water. Just in case we need more in the mix, too. We have to need more. So, bar joists. Everybody looks at this. I left a few of these out for people to look at. You guys have seen bar joists, okay? If you've ever been into a Walmart, if you've been into Home Depot, if you've been into any kind of big box area, if you look up, okay, bar joists are used for many reasons, okay? They're used because they allow for extended runs without girth. In other words, if I had to put a concrete beam to hold up from that wall to that wall, it would be immense. Okay? The weight on the point loads coming down would be immense. The amount of space it would require would kind of kill your design for open plan, open ceilings. Open bar joists give you a lot of variables. They give you the ability to run utilities through the bar joist rather than under the concrete beam. It allows you to maintain ceiling heights. It allows you to get ductwork through. It allows wiring, electrical, plumbing. And it allows the flow of air. So if you're doing a plenum rated ceiling where the area above the ceiling is actually the duct, it allows the flow of air, where if it was a steel beam and you built, a concrete beam, and you built the ceiling straight to it because you wanted that maximum height, you'd be blocking off the airflow from area to area. This allows air to completely flow. Okay, so the bar joist has more than one application, okay, more than one thing that it helps. It does require a lot of preparation. Last couple of meetings we talked about embeds that we showed that were placed in the beams, all around the perimeter, in the interior board walls. In this video, you'll start to see how those all integrate into the installation of these beams. Now, I've left a few things here for you guys to look at, okay? Some of them are just basic things, some drawings on diagonal bracing and things that are required. One of the things I left you here is a chart, okay? What this chart does is it tells you the openings in a beam you will have for ductwork. Okay? In other words, engineers can modify things, but on a standard ductwork, for example, if you have a K20, which is a 20-inch tall bar joist, and you want to put a round duct, you can get a 12-inch duct through the web. The web meaning the area across the middle with the diagonal bracing. Okay? It gives you for a round duct, for a square duct, for a triangular duct. This lets you plan earlier. Okay, go to the next picture. Okay. So for example, these are all bar joists. Okay? It's hard to see from this, but most of these are K20s, meaning 20-inch high. You will get into drawing from the manufacturer of the bar joist. It's a shop drawing. It's going to tell you how they plan on making it. A few of the things we try to do is we try to increase the length of this end web where it goes up on an angle. Okay? The reason we do that is it allows us to run ductwork tight to the wall around the perimeter and give us a free area. Because in some areas, for example, if we're going to put in square ducts, round ducts, so we're going to put in drains. Drains have to pitch and we need enough clear space. The end web allows us room to do that without affecting things like the shade pocket and other things that are going to come later because they're still above the lower beam of that, the lower member of that beam. Okay? The idea here is instead of trying to put utilities and electrical and plumbing and mechanical underneath it, we're allowed to go through. But to do that requires planning. Look at that. Okay, so for example, this is a main trunk that's got to run through. Okay? In order to get that through, that's a 14 by 10. So 14 by 10 is 16 by 12. That's how big it is. Before you do your layouts and before you approve your bar joists, you look at these. This one's going to run through joists. You try to figure out how you're going to get ductwork from point A to point B without running into a wall. Okay, so before you order these joists, you sit down with the mechanical contractor and you sit down with the structural contractor and you go back and you say, what can I do so I don't have to run the 16-inch beam below my ducts? Excuse me, my 16-inch duct below these beams. Okay? That's going to drop your ceiling height. If you're in a closet, you might not care. Okay? If you're in a gardener's bed, you might not care. If you're in the middle of a main hallway, you're going to care. So you sit and you think of this ahead of time. So if you look at this bar joist, you'll see this area is square. This area right here is square because ahead of time, before we ordered these joists, we sat down with the mechanical contractor and the structural contractor and said, how do I get a duct through that spot? Okay, now this doesn't mean we can put an opening anywhere. This means we go back to the company making the truss, they go to their engineer and say, how far from the end web does it have to be? What other crisscross members or structural modifications have to be made to allow that to be open? But because when we get this installed, we can run ductwork through it. Now for me to put this in and not have that open ahead of time would mean that I would have to run the duct below it. If that's my maximum ceiling height, then I would have a problem here. Everybody understand that? Also, these angles here are very open areas for me to run round duct through. So you could run multiple round ducts through rather than one hard duct to get distribution. Okay? It's a really good system for that, but it's not something you can think of afterwards. Something that before these get put into order, and you have to order them way ahead of time because they take time to get. Before you do any of that, you've got to go to them and say, I want this here. It may take them time to come back and tell you what you can do and what you can't. That time has to be figured into your plan. These sometimes take 3-4 months to get, which means you have to start thinking about this while you're still putting piles and grade beams in the ground. Because this has to be ordered before you get there. Okay, go back one. Okay. All this distribution around duct, this can all go through the bar joist. Okay? Although this seems relatively easy, it's not. Okay? Because in addition to this, you also have drain lines which have to run. So you have to sit down with the plumber and say, although I got this through, what is that doing to me later? In this case, the plumber had a main drain line coming across here. We shifted his drain line over, we added it in, we made there's ways you can do this, but you all have to work together. If you let the plumber run free, you let the duct guy run free, you're going to have a mess like this. Okay? Now, things come up as you go. They go back to the structural. If you look here, you see the big cloud? Right? This cloud's here for a few reasons. This stairway, for example, wasn't big enough. Okay? The owner wanted steps that were no more than 7 inches high. He wanted them less than that. In doing that, these steps became, I think, 7.2 or 7.4. In order to fix that, we had to make the step, had to increase the number of treads so that the rise or the height of each one is less. In order to get that, we had to look at the plan to see if this could widen and that could widen. And in this case, we were allowed to do it because we looked at the structural. We went to the structural engineer. We got the structural engineer to give us a stamped plan showing us how we're going to move these two beams to enlarge the area. Okay? This is all doable. A while ago I said to you, it doesn't mean because you're a professional that you're going to catch everything. It means that you're going to be able to work with what you find to come up with a real solution. That means making sure moving that doesn't affect the layout of the floor above or the location of piping coming through. In this case, this closet on this side was too big for a mechanical, and this side had already extended into the open area. It meant going back to the interior design team to make sure they understood and it gave them what they wanted. It made sure making sure going down the stairs, the clearance to your ceiling height is enough, and you're not causing an issue where now you've got a headroom problem. So just this little change right here dealt with the structural, the interior design, stair, the structural engineer. Okay? These happen. Doesn't mean it's not going to. You have to understand all the implications of what changing that means. It means to the interior designer, to your stair, to everything. Everything we do here affects other things. So understanding what all those other things are and what the implications are will tell you how to go forward.
Joe, have you ever had this architect give you a correct stair?
No. Just to go forward, since we're talking about that, this stairway here, okay, this wraps around the elevator. In this plan, this set of plans, there's nothing that tells me how that stair is built. Okay, the interior designer, until recently, didn't even tell me what they wanted to look like. Okay, and then, in their most current set of plans, they took 2 steps off it. So we're dealing with now RWB coming up with a plan on how to build with what the designer presented us to as an image, okay? As well as they having to go back now and fix that, as well as figuring out the detail for the elevator, which there was none when we got the plans. All this stuff you have to take into account as you go. Okay, so I just want you to understand why the bar joist before we go further. Okay, you want to play? Okay, so here's just stop it right there for a minute, okay? So here's where we are a couple of weeks ago. Okay, when last we talked, we were at the lower level. Now we've got the perimeter walls up. You'll see the steel beams that went in, and you'll see the bar joist running across. Okay, this is a very fast process. This whole deck, steel, everything, it took what, 3 weeks? Give or take? 3 weeks? Right?
There's water.
And a lot of water, right. Okay, so the intention here, just to go back over the whole looking ahead thing, we've got the pool frame set up so we can get the pool in. The sheet piles around are holding up the soil so we can get all this in. Along the north wall, we're putting in the wall now, we've just put in the wall. So we'll be digging all this grade out and pulling these sheet piles out. In the next lesson, you'll see everything that's come from this point, because at this point it moves fast. Okay, you want to start? Okay. There we go. Board walls, which sit on top of grade beams continually to help spread the load. These are the two beams, this one and this one, that we actually had to shift. Okay, and I'll show you that later on. But you see, the embeds you saw in the last video, you see the steel beams are welded into them. Okay, so the planning ahead to make sure your embeds are in the right place to conform with how all this is going to mount in. These are all the bar joists. This is an end that we talked about, which means I can get ductwork through all these ends. Okay? If you look here, this is all prepped in the shop drawings. The beam is brought in with preparation to receive the vertical column. Okay? Unlike when you see them putting a column into an embed in the floor, this is tight. Okay, the ones you see them in a concrete floor, there's a nut below, a nut above. It allows them to raise it, lower it, shift it. In this case, you've got your point, so you don't need to do that. All these bar joists are going to one location. Okay? They bring them in bundles and they deliver them to the area in bundles when the weight of them is not so excessive that they can't be handled by hand. Okay? When they get too big, they go one at a time. But when all these go into one section, they can move it, they will. Okay? These come in marked, just as if you were buying something from IKEA and it had used part A1, A2, A3. They have a plan. And part of that plan is which bar joists go where. If you look at the bar joist that I showed you a picture of that had the opening in it, that bar joist not only had to have an area, because there's other bar joists next to it that look the same without that opening, but it also has to have a direction. Because if the bar joist is set this way, the hole's over here. The bar joist is set this way, the hole's over here. So they have to know which way it's going, and that usually implies us getting involved more than just handing them a thing and saying going. Okay? Good. So you'll see the longer section of bar joists of one at a time. Okay. So here you see all the different parts that we talked about previously. This long section at the end web, if you made this a square where it butts up to the wall, you would see how much room that's actually giving you to run things above the ceiling height. The key thing here is what's above the ceiling height and what's below the ceiling height. These go into place and all these ends tie into a welded embed or a piece of steel or something that was predestined to work that. Like we said, when you get to here and you see long joists going in, which is probably where this one's going, they're individual, okay? You can't, it's not two guys, it's not only that they can't handle it, but they can't handle it safely. These guys are really good at what they do and they know the limit of what they can do, and they tend not to go beyond that limit because their lifespan would be very short, okay? Doing this, you got to watch where you step. You got to watch what you're doing. And if you're welding, you got to watch what's below you. We tell the guys to take cones. If you're welding, take cones on the floor below, wrap it so nobody walks into that opening. In this work, more than anything, hard hats are really, really important. Not just because something could drop on your head, but an ember from them welding could come down and really hurt you. Okay? You got to be really focused when you walk around a site when this is going on, more so than ever, because there's a lot going on. And the guy who's concentrating on this is not looking down while he's welding here. Good. Okay. These are done this way for a reason. When they bring them to the back, they could set one, put it in place, unstrap it, go to the next one, set it, because they can move these at one time rather than coming back 5 times. Okay, so they'll set the first one in place, get it locked, untie it, bring the next one over, set it in place, untie it, bring the next one. These they can handle that way. So when they do it, again, they have to know how to strap it and how to get it so it goes the right way. Okay. You can see how far those are going. You can see the guys waiting to take them. You see, if you can look, you see the embeds that were put in along the top and here? Okay. These are the vertical columns that are set in place. Okay? If you look, there's Nelson studs at the top. We've talked about Nelson studs on previously used for embeds and such. Where there's a Nelson stud going in, you can tell it's going to be a concrete column above it. Okay? And if you look at this, you can see that we don't have that birthday cake effect we talked about. These columns are supported by beams below. If this column was concrete, it would probably be this wide and about that high. Because this has to carry all the load from these columns up to the upper floor. All that is point loaded right there. Okay, so if you remember in an earlier meeting, we talked about a point right here where the architect had a 6-inch column and he said, I don't know if 6 inches is enough, and we changed it to a concrete column on site. That's the area, and this is the reason. Because the whole load of this beam and everything this beam is carrying, which is upstairs, is on that point. So when the engineer came in, he said, I don't think a 6-inch column is going to cut it. And we had to redesign this section and put in a concrete column. He's looking at how that load is transferred. So things like this are necessary. They come in, they're looking at the finished product, we should be looking at it too. Okay? So all these points here, these are all located on the drawings and they're noted by the steel fabricator. Okay? Embeds. I don't know if you remember when Devin was talking on the previous walkthrough on the video, he showed you all the embeds being put in the wall. Now you can see why. Steel's being tied into the embed. All this, there's an L that's been put on the embed, everything will sit. Everything gets tied into the structure. There's really two ways they do this. They either put the L, which welds to the front and it sits on top, okay? Or it'll be in the top, okay? But this has to be completely welded as an infrastructure. If you've ever heard anybody say, this makes a manifold, okay? When you do something like we have the exterior of the wall all excavated and there's no weight on it, right? Because the weight is taken off because we have the sheet piles in. The engineer tells us specifically we cannot backfill around it until we complete the manifold, which means we put a membrane across this whole top that's going to support those outside walls. That's what all this is doing. Okay? Good. All these structural elements in the beam are put there because they carry the weight of these above. These are all design elements that the structural engineer decided he needed to have put in this beam in order to counter what's coming afterwards. Okay? This all appears on the shop drawings from the steel fabricator, and these all have to be approved ahead of time by the structural engineer. Very rarely have I ever seen these drawings come back approved first time. Okay? Because the structural engineer is looking at the drawing, the fabricator is looking at the drawing and making sure it matches the drawing. The structural engineer comes back and he reevaluates as he goes, do I have enough support? Just like that column. And he may change something at that phase. Okay? But all this horizontal girder that was added here, all this is part of the structural design. And all this weld gets inspected. And you have to make sure it gets inspected. And I highly recommend you have the structural engineer come in and do a walkthrough at some point in this part of the process. Okay, looking from above, Nelson studs for the next angle. Now before you go further, you see all these here. See the flat plates? Flat plates without Nelson studs are probably getting steel columns. With Nelson studs are probably getting concrete columns. These you have to make sure before you go any further, they're plumb and true. Because later on, chances are, on an exterior wall, these are all going to have doors and windows people in them. And being out of plumb by 3/4 of an inch is going to be a disaster for you later. Okay? Okay, just stop for a second. You see these lines running this way? If you look on that drawing I gave you, this thing not only has to be welded, it also has to be braced. So if you look at this, you'll see, and I don't want to spend too much time on it, you'll see horizontal bracing and diagonal bracing. This does is if you have all the joists like this, It locks them from twisting, moving, bending, keeps everything rigid, okay? Steel, when you weld it, likes to heat up and move, okay? These are all just measures to make sure this happens. Sometimes those cross members and the bracing gets in the way of what you gotta do. If it does, call the engineer, ask him, can I cut this and weld it here, okay? Doesn't mean everything's locked in stone, but that bracing's very important. And just when you think you're done because he's put them all in, and he brings the bracing in, and you're like, oh shit, I got another week, okay? But let it happen, go ahead. And here you see this open. This is between the sheet pile and the wall, okay? The engineer gave us approval to backfill up to 6 feet because it doesn't put too much stress on the manifold. If this wasn't in here and I backfilled this wall, you can see how much pressure would be on that poured concrete wall. That concrete wall is not meant to have strength diagonally. It's meant to have point load. Okay? The strength of that wall is downward. It's not as much laterally. So we have to, once this manifold's in and that's poured, if I backfilled against it, that wall's designed to hold it with the manifold supporting the wall. Without the manifold supporting the wall, if you backfill, you're on your own. Okay? Usually it's good to have a letter from the engineer, send him a photo, say, look, floor deck is in, and he'll say, go ahead, backfill. And also assuming you've met PSI rating on your concrete. After everything's in, including your diagonal bracing, including your bracing so your whole web is completed, then you bring in your deck. Okay? The deck is also specified by the engineer to make sure you have the right one. Also requires a shop drawing with a signature from the engineer. Okay? It'll continue all the way across, and you'll see where it goes after. This is called puddle welding. Okay? In this case, he's welding this down to the bar joist below. So every one of these welds in the decking goes to the bar joist. This, make sure if this goes in, at this point you may feel you're safe to walk underneath because everything's pretty much closed up. This puddle welding will shoot sparks, it will come down, it will affect whoever is underneath. Be real careful of the area below this because in all these cases, they're not really able to keep track of where the sparks are flying. And that stuff will hurt you. You get it in your eye, believe me, you're blind. Okay? In the previous classes, we talked about how things change. This is an area where we opened the doorway to the side from the garage. And now that it's done, you can see it. We did the poured header going straight across, cut into this, that was already done. This was an add. And if you looked at the drawing that we did originally that was clouded, this is one of the areas that was clouded. Okay, afterwards, you can't tell you ever did anything. But these are the things you have to keep track of. Go ahead. Okay, we talked about having to make the stair larger. Here, you see the plate? That was the original embed. What we did is we went back to the engineer. We said, I want to move this beam 1 foot this way, and I want to move that beam 1 foot that way. In order to do that, we welded a plate onto the original embed and bolted the other side. We got a detail from the structural engineer to do it. That allowed us to move this beam this way and this beam that way. That gave us a 2 foot larger opening of that stairway, and that piece of steel had to be replaced. Okay, we had a sketch on it, we did it, it got approved. You're going to catch these things on site. They're going to happen. Okay, and when it comes to a stair or something like that, it affects everybody. The structural, the framer, the air conditioning guy who's got his equipment in there, you know, whatever's happening, make sure you look at the impact of all the other trades before you say, yeah, I'll just move that a foot. Go ahead. Okay. Many of you guys have seen this, okay? After the deck is down, we have electrical that has to go on the floor. We have electrical floor boxes. In this case, we had to go back to the designer because the floor boxes usually relate to their furniture plan. Where's a light go next to a couch, something like that. They have to give us a CAD drawing showing the location of all these boxes. So you'll see two things, you'll see a few things here. One, you'll see conduit running up for things like lighting panels, electrical panels. In this case, there's panels in this room that's going to be here. You'll also see sleeves put in. Okay, these sleeves are put in by all the trades, air conditioning, electrical, plumbing, Plumbing is usually green, okay? The reason they do this so they don't have to core drill later. Saves them time. I like when they do this because it forces them to think through how they're going to proceed after this is done. If you wait till they core drill it, then they start thinking about it then. If they have to put these sleeves in the right place, they're thinking, how am I getting my pipe from here up? Where is that wall? Where is it going from there? Everybody putting these sleeves in now means that everybody's thought out. It also means that no one's going to come back later and say, that core drill is mine, it's not yours. You didn't drill that, I did. Okay, anybody who's been here knows that that happens all the time. Okay, so getting the guys to come in weeks before, at your weekly site meetings, go through, does everybody have their locations? Does anybody need anything from the designer? Everybody have the wall location? Everybody know where the floor boxes go? You've got time to do it. Don't let them come back to you like the day before the pour and say, I don't know. Okay? A good plumbing contractor will be able to lay his whole house out for vents, drains, water lines, everything. Okay? Okay. Cages for the next step. Why? Because you're still working on what's happening next. Okay? You're still looking at, I can start putting my vertical columns in. You're still saying, you're not, everything you're doing is fluid. Okay? If you wait till this is completely done before you think ahead, this house is going to take you 5 years. Okay? Where possible, start working to the next phase early. Okay? Okay? See this bolted section? This is for column. Okay? The reason there's bolts in it is because it's going into a concrete beam. Okay? That beam, when they made the column, that column was off. So they had to remake the column. And again, here's a perfect situation where the bolts are sticking up. It allows them to raise, lower, and make sure it's perfectly plumb. Okay? That will be taken care of before the pour. Go ahead. Electrical boxes. These are electrical floor boxes. After the pour is floored, they cut, and the floor is in, they'll cut them to height. Guys who've ever done this, you know how that works. These squares, these are shower recesses. Because if you put in showers where you step down, if you pour it straight across, you're not going to have that step down. So the engineer specs, in this case a metal box, to put in, we have to make sure we give them the right location. Okay? You could be off a little bit, not that much. We usually enlarge them, sometimes not, depending on if they fit between walls. Okay? But if you look, when we get this, we give them a dimension from that to the outside wall of the building, which is always going to be a constant. Okay? We go from this to this step down, which is always going to be a constant. Try to avoid giving them from an interior wall location. This interior wall location is laid out off the exterior walls here, adding one more element of possible issue. Okay, always go from a fixed point. Okay, hold up a second. Okay, see how around here we haven't gone all the way to the elevator? Everything stopped short of the elevator. Okay, the same thing happens if you look at walls over here. Okay, when you build a structural wall that's continued from the lower level all the way to the roof, you don't want a steel pan between them. You want that to be one layer of concrete poured from the bottom all the way up. For that reason, this deck stops short. Because if not, this deck would extend in, there'd be a gap, and then you would pour the wall on top. That's an extreme weak point. Okay? So whenever you see structural walls like over here, you'll see that the deck is cut. Because you want to pour concrete to concrete. You don't want to pour concrete, set a deck, and pour concrete on top. Like you said before, you have vertical cages going in now. Okay? That's to get from this slab up. This means we're continuing. Even though this isn't done, we're continuing. Okay? This is a matter of being expeditious and keeping things moving. Okay? See all the sleeves for the plumber, electrician, etc.? That's how much thought process had to go in ahead of time. Okay. Rebar and cages for the next floor. Everything has to continue through for a structural wall. Okay? before you get past this, before you get to the pour, and Randy will tell you this, have someone or a group of people go through and make sure all the stuff's out of that deck. Scraps, bottle caps, cut pieces of steel, pieces of conduit, things that people you might not even think of. You want this deck clean. Pick it up, blow it out, do whatever you gotta do, but do not pour this deck until you go through it and make sure it's clean. Everybody understand that? Okay, at this point, everything's been inspected, everything's done, and we pour the deck. Okay, you can see all the sleeves, you can see columns that went in, and we're extending to the back. At this point, we've also started building the frame around the pool in preparation for extending out. Well, the columns are pretty much already started going up to the next phase. Everything we do here, and I've said this from day one, is a matter of planning. It's thinking what your next step is before you get there. If you don't, it will come back to bite you. That's structural, that's plumbing, that's electrical, that's bar joist, that's everything. And it doesn't just mean will the building hold up, it means will the interior design plan work. There are things you'll find that don't work at all, and you go back and say, what were they thinking? You have to catch them early. Everybody good?
Guys, first and foremost, I want to thank Joe for doing these classes. You know, putting this together, even though we're running a couple of months behind, this is something that Joe spends his personal time getting ready for you guys, so thank you, Joe.
Appreciate it. Thank you.
Second, if you're listening this morning, right, I don't need you to know, as you grow in this business, every part and piece of what Joe just talked about. That'll come in time. But if you hear over and over and over again, communication, communicating with subs, communicating with our own teams, communicating what needs to change with the design team, with the architects. Guys, it's the biggest part of what we do for a living. We move data from one place to the next. The actual physical work of this is not as complicated as preparing for and making sure that we are doing the correct things. And that all comes in part with the communication piece of what we do for a living. Clear? Quickly, let's move to Monday morning meeting. You got anything else?
I'm good.
You're beautiful.
Yep.